Let's play a fun game I invented called Which Solution Has the Higher Concentration. In chemistry, when we're talking about concentration, we often talk about molarity, which is the unit's capital M. Molarity is the moles of the solute, which is whatever is dissolved into the solution, divided by the volume of the solution in liters. So let's look at our first solution. We have solution A. It has 6 particles, we'll call those moles. It has 6 moles and 600 milliliters of total volume. Solution B has some number of moles we'll count and 300 milliliters of total volume. Solution C has 6 moles and 300 milliliters of total volume. And solution D has some number of moles and 600 milliliters of total volume. The numerator for the equation for molarity is moles. So if you count them up, we have 6 moles, 12 moles, 6 moles, and 15 moles. And we also have the volume for each one, which will go into the denominator. So we have our volume, but notice how our volumes are in milliliters. It's common to measure volume in milliliters, but when you're calculating molarity in chemistry, you need to convert your milliliters into liters, and we do that by dividing by 1,000. So now we can calculate the molarity of each solution. So at this point, it's simple division. We have the first solution, which has a molarity of 10 molar, that's how you say it. The second solution has a molarity of 40 molar, so it's looking pretty concentrated. So you can think of it as like the solutes are kind of bunched up into a smaller volume. And then we have solution C, which has a molarity of 20 molar. And then we have solution D, which has a molarity of 25 molar. So we see that solution B has the highest concentration. It has the most moles of the solute in the given amount of space. Oftentimes when you talk about molarity, or when you have to calculate molarity, you won't necessarily be given moles, you might be given grams and have to convert. So let's see what that looks like. Let's do a practice problem. What's the molarity of a 500 milliliter solution containing 30 grams of glucose, which is C6H12O6? You usually need to know the formula so that you can calculate the molar mass, and I'll show you why that's important. And that's because if we look at the equation for molarity, it's moles, not grams. So we need to convert our grams into moles. So to do that, we're going to take 30 grams of glucose, C6H12O6, and we're going to convert that from grams into moles. So grams will cancel out top and bottom. If you calculate the molar mass for glucose, you'll get approximately 180 grams per mole. That means that 30 grams of glucose is equal to about 0.167 moles of glucose. And moles of glucose is what we need for our equation, so let's save that. Our equation is almost complete, but what about the volume? It says that the volume of this solution is 500 milliliters, but our equation says we need to have liters to be the standard unit. So to convert your milliliters into liters, you just divide by 1,000. It takes 500 itty-bitty milliliters to make 1/2 of a liter. So we can put that in our equation, 0.500 liters. And we're ignoring sig figs, so we can put a little decimal point there if we wanted to. If you do your math, then you're going to get an answer of about 0.33 molar. So that's how you say the answer. That would be the concentration or the molarity of a solution that has 30 grams of glucose dissolved within it, and the total volume is 500 milliliters. Here we have another problem. It says determine the mass of sodium chloride solid to make a 250 milliliter solution with a concentration of. That's what those square brackets around something means. If you see the square brackets, it means concentration of whatever's inside. So the concentration of the sodium chloride will be 0.40 molar. So this would be the molarity. So if we write out our equation, we can actually fill in some things. Sometimes you can write out the equation first and rearrange it after, or you can fill it in, but you're going to have to rearrange it anyway. And that's because the equation is molarity is equal to moles over liters. But we actually need to find moles so that we can then find mass. So we're going to take this equation and rearrange it. And we're going to get that the molarity times the volume in liters will be equal to the number of moles. So I just used algebra to rearrange the molarity equation because we want to solve for moles. I filled in the molarity and I filled in the volume, but notice how I turned the volume from milliliters into liters because that's the standard unit. And to convert milliliters into liters, I divide that by 1,000. You can review your dimensional analysis to remember how to convert between metric units. So if you do your math here, you're going to get about 0.1 moles. So we have 0.1 moles, which is how many moles of sodium chloride you would need. But it doesn't ask for moles, it ultimately asks for grams. That means that this is actually a two-step problem. So we're going to take that 0.1 moles of NaCl, and we have to convert that from moles to grams of NaCl. So we have to look at the molar mass, which is the mass of Na plus the mass of Cl. And that's going to give us about 58.44 grams per mole. So what we're going to end up doing is canceling out the moles, and then we're going to be left with grams, so that's what we want to do in this case. And we're going to get about 5.84 grams of sodium chloride is necessary to create a 0.4 molar solution of sodium chloride with a volume of 250 milliliters.